Imagine standing on a platform made of pure light, looking down at a sphere so massive that if you flew a commercial jet around its equator, the journey would take over 1,100 years. Your entire world, your history, and everyone you have ever loved would be a microscopic speck of dust lost in its shadow. The universe does not care about our scale, yet we are built from its wreckage. Can you feel the weight of that silence? Understanding the life and death of stars is the only way to understand our own arrival. These celestial engines forge the very atoms in your blood, and by mapping their diversity, we map the limits of physical reality itself. Our journey begins with the embers of the cosmos. Brown dwarf you could technically walk on the surface of some of these objects without burning, though the gravity would instantly crush your skeleton into a thin paste, often called failed stars. Brown dwarfs lack the mass to ignite hydrogen fusion in their cores. They sit in the dark territory between the largest planets and the smallest stars, with masses ranging from 13 to 80 times that of Jupiter. Their temperatures are eerily low, ranging from a chilling 300 K 80 F to about 2,800 K 4,580 F. Imagine a world the size of Jupiter, but 80 times heavier, glowing only in the infrared. Kevin Luhman used the WISE Wide Field Infrared Survey Explorer telescope to discover WISE 0855 find 0714, the coldest known brown dwarf, which actually has signs of water ice clouds. These dim orphans prove that not every cloud of gas achieves its destiny. Brilliance! Red dwarfery, single one of these stars ever born, is still shining today, and they will continue to do so long after every other light in the sky has gone dark. Red dwarfs are the endurance runners of the universe, with lifespans reaching up to 10 trillion years, nearly 1,000 times the current age of the cosmos. These M-type stars are small, possessing between 7% and 50% of our sun's mass, with surface temperatures hovering around 3,500 K, 5,840 F. If a red dwarf replaced our sun, high noon would look like a deep, blood-red twilight, and Earth's oceans would freeze solid in days. The Kepler Space Telescope and the TESS mission have revealed that these stars are the most common in the galaxy, often harboring rocky planets like those in the TRAPPIST-1 system. They are the quiet, steady hearths of the universe, yet they harbor a volatile secret that leads us to more active neighbors. Orange dwarf, these are the Goldilocks stars of the galaxy, providing a stability that puts our own sun to shame. Orange dwarfs, or K-type stars, are slightly smaller and cooler than the sun, with masses between 0.5 and 0.8, solar masses and temperatures ranging from 3,900 K, 6,560 F to 5,200 K, 8,900 F. While our sun will become unstable in a few billion years, an orange dwarf can remain steady for up to 70 billion years, giving life a massive window to evolve. Imagine a sun that stays middle-aged for 6 times the current age of the universe. Using the HARP spectrograph, astronomers like Francesco Pepe have studied Alpha Centauri b, one of our closest orange neighbors, searching for Earth-like worlds in its habitable zone. They represent the ultimate sanctuary for life, far more hospitable than the more famous stars that follow. Yellow dwarf, despite what you were taught in school, these stars are actually pure white. The atmosphere of your planet is simply lying to you. Our sun is a G-type main sequence star, a yellow dwarf that converts 600 million tons of hydrogen into helium every second. It maintains a surface temperature of approximately 5778 K, 9941 F, and has a predicted lifespan of about 10 billion years. If you could stand on its surface, the gravity would make you weigh 28 times more than you do now, turning your own body into a leaden weight. The Parker Solar Probe, led by Nicola Fox, is currently touching the Sun's corona to understand why its outer atmosphere is millions of degrees hotter than its surface. It is a terrifyingly precise clock, ticking away toward a transition that will eventually consume the inner solar system. Subgianthus is the first sign of a star's midlife crisis, a bloating that signals the beginning of the end. A subgiant occurs when a star like our Sun exhausts the hydrogen in its core and begins to expand, becoming brighter and cooler as its outer layers swell. They are roughly 1.5 to 8 times the luminosity of the Sun, with temperatures dropping slightly as the surface area increases, often around 5,000 K, 8,540 F. Imagine the Sun growing so large that it fills half the sky, turning the midday heat into an inescapable furnace.